A lithium-ion, or Li-ion cell, is a type of rechargeable battery that's widely used in consumer electronics, electric vehicles, and energy storage systems. It's popular due to its high energy density, long cycle life, and relatively lightweight design. Key components of a lithium-ion cell. Anode, or the negative electrode. It's typically made from graphite, which is a form of carbon. The anode stores lithium ions during discharge and releases them during charging. Cathode, or the positive electrode. It's made from lithium metal oxides like lithium cobalt oxide, lithium iron phosphate, or lithium nickel manganese cobalt oxide. The cathode provides lithium ions during charging and stores them during discharge. Electrolyte. A liquid or gel substance containing lithium salts, such as LiPF6, dissolved in organic solvents. It facilitates the movement of lithium ions between the anode and cathode. Separator. A porous membrane that physically separates the anode and cathode. It prevents short circuits while allowing lithium ions to pass through. Current collectors. Copper foil for the anode and aluminum foil for the cathode. They conduct electricity from the electrodes to the external circuit. So how does a lithium-ion cell actually work? Let's talk about the charging process. During charging, lithium ions move from the cathode to the anode through the electrolyte. At the same time, electrons flow through the external circuit to store energy. Now let's look at the discharging process. During discharging, lithium ions move back from the anode to the cathode. This movement generates an electron flow in the opposite direction through the circuit, providing power. Alright, let's talk about the advantages of lithium-ion cells. High energy density means more energy can be stored per unit weight, which is really efficient. They have a long cycle life, allowing them to undergo hundreds to thousands of charge-discharge cycles. Plus they have low self-discharge, meaning there's minimal energy loss when not in use. And they are lightweight, making them perfect for portable electronics and electric vehicles. Now let's look at the disadvantages of lithium-ion cells. First off, cost. They're more expensive compared to other battery types. Then, there are safety concerns. They can overheat and cause thermal runaway if damaged or improperly managed. Over time, they degrade, with capacity decreasing due to electrode wear. And finally, recycling challenges. They require proper disposal because of the toxic materials involved. Moving on to the applications of lithium-ion cells. In consumer electronics, they power our smartphones, laptops, and tablets. In electric vehicles, they are used in models like Tesla and the Nissan Leaf. For energy storage, they're crucial in battery energy storage systems for renewable energy grids. And in the medical field, they're found in portable medical equipment. The nominal voltage of a battery refers to its typical operating voltage during normal discharge. Nominal voltage of lithium-ion cells is 3.6 volts or 3.7 volts per cell, which is quite common. This value can vary slightly depending on the cell chemistry. Voltage range of lithium-ion cells. Fully charged voltage 4.2 volts per cell for most chemistries. Charging beyond this voltage can cause damage or safety risks. Nominal voltage 3.6 to 3.7 volts per cell. Cutoff voltage when fully discharged, typically 2.5 to 3 volts per cell. Discharging below this voltage can permanently damage the battery. Nominal voltage for different lithium-ion chemistries. Battery chemistry, nominal voltage, fully charged, cutoff voltage, lithium cobalt oxide, or LCO. 3.7 volts, 4.2 volts, 2.8 volts, lithium iron phosphate, or LFP. 3.2 volts, 3.65 volts, 2.5 volts, lithium nickel, manganese cobalt, or NMC, 3.6 volts, 4.2 volts, 2.5 volts, lithium titanate, or LTO, 2.4 volts, 2.8 volts, 1.8 volts.